everyone. This is the third lecture of our example number 1, which is the design of cantilever retaining wall. So students, in the first lecture we are discussing about our step number 1, which is coefficient of earth pressure. Okay. After that we are discussing about our step number 2, which is to find out preliminary dimensions. And after that, basis on our preliminary dimensions, we have to find out our stability checks. So students, it is already discussed in our introductory section that there are 4 preliminary checks. So first preliminary checks or first stability checks is the stability against overturning. Second one is stability against sliding. Third one is our maximum pressure, which is at the toe side, is less than soil bearing capacity. And our last is no tension at base. It means our minimum pressure is always be greater than 0. Okay. If our minimum pressure is less than 0, then it is considered as it is tension at base. Okay. So now let us start our step number 3. So in step number 3, first of all we have to find out horizontal force at left corner. So our leftmost corner is A point. So we have to find out all the forces and all the moments at the bottom of toe slab. Okay, so now let us start our step number 3, which is stability calculations. So first of all, we have to find out our horizontal force. So which component is act as a horizontal force, or which component is try to retaining wall about horizontal force. So it is backfill and soil. So you all know that our soil is at this portion. This all the portion is covered with soil. So whenever this is our retaining wall, so whenever this soil is acting on this side, okay, so this soil is try to retaining wall about sliding or overturning. So how much force is acting on the retaining wall? So you all know that this is our topmost portion of retaining wall and this is our lowermost portion of retaining wall. This portion is provided only for prevent the retaining wall against sliding. Okay, so our soil is at this height. This height is 6.7. So you all know that with the increasing in the height, our pressure will be increased. So this is our pressure diagram. Increasing in the depth, it means it is increasing in the pressure. So what is the equation of pressure at the base? So our equation of pressure at the base is K into gamma into H. But we have to find out force. So you all know that it is already discussed in our introductory section that in this chapter, whenever we have to find out force, then we have to find out area of pressure diagram. Okay. So what is the area of pressure diagram? So the area of pressure diagram is 1/2 base and altitude. It means 1/2 K into gamma into capital H square. So now let us start our horizontal force calculation, in which first column is load type, means which component is acting as horizontal. So it is called as active earth pressure, because you all know that this is our retaining wall, this is our backfill. Our backfill is trying to move away. So the force which are acting at the retaining wall and try to move away the retaining wall, it is considered as active earth pressure. So this is our active earth pressure. The horizontal load equation is area. So what is the area? Area is 1 half base altitude. So our answer is 134.67 kilonewton. Now, you all know that any force is acting at the CG point. So our total height is 6.7 and the area is triangle. Shape is triangle. So what is the CG of triangle? The CG of triangle is h by 3 below level and 2h by 3 at the upper portion. But we have to find out all the forces and all the moments at this point. So this is our force. Whenever this force is acting at this point, this is our CG. So this height is h by 3 and this h height is 2h by 3. So this h by 3 is 6.7 divided by 3. Now force into perpendicular is the moment. So you can see that whenever this force is acting on this side and this force is transferred to this point, then it is generated anti-clockwise moment. Okay. So what is the value of moment? The value of moment is force into perpendicular, which is 300.31 kilonewton into meter. So this is the calculation of horizontal load and moment. Okay. So our horizontal force is called as sliding force and our moment is called as overturning moment. Okay, so this is the calculation of horizontal force. Similarly, we have to find out vertical force. So, vertical force is acting due to self weight of retaining wall. Okay, so you can see that this is our stem portion, but we have to cut the stem portion in such a way that it is partially good area. So, this stem is cut by this portion. So our this portion is rectangle. Our second portion is triangle. This is our third portion, which is called as base slab, is also rectangle. This is our fourth portion is shear key, and some portion retained by retaining wall is called as backfill. So your soil which is at this portion is try to give downward force on this retaining wall. So there are generally five types of load. First one is stem portion 1, second one is stem portion 2, third one is base slab, fourth one is shear key, and fifth one is backfill. Okay, and we have to find out all the moments at lower left corner which is at A point. Okay, so now what is the area of part number 1? So our area is 0.2 into this height. This height is 6.2 meter because our overall height is 6.7 meter, but our thickness of base slab is 0.5. So our this height is 6.2 meter. So our area is 6.2 into 0.2. Now which material is provided inside the retaining wall? So retaining wall is constructed with the help of RCC. So what is the density of RCC? The density of RCC is 25. So our final force is 25, which is the density into zero point 0.2 into 6.2, and we have to find out all the forces per meter length. So it is into 1. Okay. So this is our stem 1 calculation. Now what is the distance? So you can see that this length is 0.2. Now what is the CG? CG is 0.1. Okay. But what is the distance from here? So this length is 1.2. This whole portion is 0.45, but this is 0.2, so this is 0.25. So this length is 1.2 plus 0.25 plus 0.1. So total CG distance is 1.55 meter. Okay. Now force into perpendicular distance. So we will get our answer moment. So you can see that whenever this force is acting on downward side and reaches at this point, then he is move as clockwise direction. Okay. Now, the second term is stem 2. Now, what is the area of stem? The area of stem is triangle 1 half base altitude. So, 1 half base is 0.25 and altitude is 6.2. Now, which material is provided? The material is concrete. So, it is 25 into 1. So, our answer is 19.375 kilonewton. Now, what is the distance? So, distance is 1.2 plus this CG. CG is over here. So, this distance is 1 by 3 and this distance is 2 by 3. So, we have to find out all the distance from this side. So, our distance is 1.2 plus 2 by 3 of 0.25. Okay. So, this is the area of second portion. Our third portion is base slab. So what is the area of base slab? The area of base slab is this is 4 meter and this is 0.5 meter. So 4 into 0.5 now 25, which is the density of concrete. So our density of concrete is 25 into 4 into 0.5 into 1. So we will get our answer 50. Now what is the CG? This is length is 4. So 4 divided by 2, which is Z2. Okay. So 50 into 2. So you will get your answer 100 kilonewton into meter. This is your portion number 4. Now, what is the area of this portion? The area of this portion is 0.45 into 0.5 into 25, because we have to fill concrete in the shear key. So, what is the value of force? The value of force is 5.625 kilonewton. Now, what is the distance? Distance is 1.2 plus 0.45 by 2. Okay. So, it is 0.225, which is equal to 1.425 meter. Now, moment is force into perpendicular distance, and last one is backfill. So, backfill is provided over this portion. So, what is area? Area is 2.35 into 6.2. Now, which material is provided? The material is soil. Now, the density of soil is 18. So, our force is 18 into 2.35 into 6.2 into 1. So, we will get our answer 262.25. Now, what is the CG? Our CG is, this is 1.2, this is 0.45. Now, the CG is at the center because this area is rectangle. So what is the center? The center is 2.35 divided by 2, which is equal to 1.175. So our total distance is 2.825. So our final answer is 740.88. Now, what is the value of total self weight? So, total self weight is the summation of all the 5 components, which is 368.26 kilonewton, and our total moment, which is called as resisting moment, is 923.49 kilonewton into meter. Okay. So, students, in this step, we have to find out horizontal force and horizontal moment. Second one is vertical force and moment. This all the moment is acting as clockwise. So you have to clear that your horizontal force and due to that moment is considered as anti-clockwise, and your vertical force and moment is considered as clockwise. Okay. So students, in the next lecture we have to find out our stability checks, which is already discussed in our introductory section. Okay. So this is the end of today's session. Thank you.